Hi, this is the next video for the Year 1 Pure. We're looking at 8a. The binomial expansion, binomial, of course, to numbers. There they go, two numbers. Now we know that a plus b to the 0 is 1. We also know that a plus b to the 1 is 1a plus 1b. A plus b squared, 1a squared, 2ab, 1b squared. Now a plus b cubed, I haven't memorised this, I'm just using the triangle. And this is what it's all about. Working out these expansions using the triangle. I'll do the next row. Just pause it for a second. Just have a think about how I've got the numbers, what's going on with the powers, and maybe think about what the next line might be. Okay, so the patterns here, look at the powers of A. Powers of A always start with the power of the bracket. A cubed for a plus b cubed, a to the 4 for a plus b to the 4. So not surprisingly, the beginning of the next line will be 1a to the 5. Now the powers of A are decreasing. 4, 3, 2, 1, nothing. And the powers of B are increasing. B to the 0, b to the 1, b squared, b cubed, b4. And because the powers of A are decreasing and the powers of A are increasing, they always add up to the same. They always add up to whatever the power of the bracket is. So if we know the patterns in the powers, we could also work out these coefficients. Coefficient just means a number which is multiplied by. So the coefficient of a cubed b is 4. Well, 4 came from adding the 1 and the 3. 6 came from adding the 3 and the 3. So each coefficient comes from adding the 2 above it. So the next term here will be 5, reduce the power of A, increase the power of B. Add the two powers, reduce the power of A, increase the power of B. And of course they always add to 5 because I'm trying to raise this, I'm trying to expand this bracket to the power of 5. A squared B cubed, 5a b to the 4. So the coefficients 1, 5, 10, 10, 5, 1, 1, 4, 6, 4, 1, 1, 3, 3, 1, they're always symmetrical, and the powers of A and B always add to give the power that I want. Pascal's triangle is the name given to the triangle that's formed just by the numbers, forgetting about the A's and B's. So example 1 says, use Pascal's triangle to expand x plus 2y cubed. Well, I recognise that it's a power of 3, which means it's the 4th row. I know, because I've done this a billion times, and also because I've worked it out, I know that my coefficients are going to be 1, 3, 3, 1. So what I'm going to do is I'm going to expand a plus b cubed, 1, 3, 3, 1, a cubed, a squared, a, no a, no b, b to the 1, b squared, b cubed. And then I'm just, instead of a I'm going to write x, instead of b I'm going to write 2y. So x plus 2y cubed is 1 times x cubed plus 3 times x squared times by 2y. We'll simplify that next step. 3 times x times by 2y squared, and then 2y cubed. So my full expansion then is x cubed plus 6x squared y. Now this 2y all squared is 4y squared, so 4y squared times 3x, 12xy squared, and 2y all cubed is 8y cubed. Done. If we have negative terms, we need to be a little bit more careful, but the maths is the same. As long as we use brackets, then we're good. So I'm going to expand a plus b to the 4. I'm going to, well, I know that it's 1, 4, 6, 4, 1 because I've done it a lot, but also I could use Pascal's triangle. And I know it starts a to the 4, a cubed, a squared, a, no a term, no b term, b squared, b cubed, b to the 4. What I actually want to expand the question is 2x minus 5 to the 4. So I've replaced my a with 2x and I've replaced my b with minus 5. And I use brackets a lot. 2x cubed times minus 5. 6 times 2x squared times minus 5 squared. 4 times 2x times minus cubed, I can just fit it there, plus minus 5 to the 4. Okay. Well, 2 to the 4 is 16, so 2x to the 4 is 16x to the 4. Straightforward enough. This is going to be a negative term because my minus 5. So I've got minus 5 times 4, that's 20. 20 times 2 cubed, 20 times 8 is 160. So minus 160 x cubed. This is going to be positive because my negative term is squared. 25 times 6, that's 150. 150, 2 squared is 4, so 150 times 4 is 600. So plus 600 x squared. Negative again because my minus 5 will be cubed, so it's going to be 5 cubed, that's 125. 125 times 4, that's 500. Times 2 is 1000, so minus 1000x. And then minus 5 to the 4 is positive 625. So again, as long as I use brackets appropriately, the maths is the same. Just do need to be careful about those negatives. Example 2, I just want to look for a specific term in an expansion. So the coefficient of x squared in 2 minus c to the x cubed is 294. Find c. Well, this is a cubic expansion. Now I know that my cubic expansion 1, 3, 3, 1. I want the x squared term, the term for which my cx would be squared. That's the dog shaking you can hear. So if I think about my 2 being my a and my minus cx being my b, I want the term that has b squared. Well, this will be b to the 0, b to the 1, b squared. It will be this one, won't it? So it will be b squared. Now, remember the powers add to 3. So a, b squared. That's the term I'm interested in. They've told me that the multiplier of x squared is 294. So, the 3ab squared, 3 times by a times by b squared. Well, that's my x squared term, so that's equal to 294 x squared. So 6c squared x squared is 294 x squared, 6c squared is 294, which means c squared is 49 and c is 7 or minus 7. So we don't need the whole expansion for this particular question, so I've been a little bit skillful about it and not wasted a load of effort because I only care about this one term. Okay, have a go at 8a. Let me know if you need anything.